Okay, now let's proceed to see the demonstration of one-way repeated measures of ANOVA using an example dataset. So this is a dataset, and actually I obtained this dataset from the layered statistics website. So the labels are the outcome variable is the concentration of the C-reactive protein level, and the related categories are the CRP level measured at the pre-intervention, and the CRP measured at the midway intervention, and the CRP level measured at the post-intervention. So the time interval which the CRP was measured is a related predictor variable having a related categories, So here is the data set. There are 10 observations or sample size for each related groups of this repeated measures ANOVA. So as usual, click on Analyze and go to General Linear Models. Previously, we have used the univariate icon, the multivariate icon, and now this time we use the repeated measures ANOVA. So click on the repeated measures. So here is a box which says repeated measures, and there's a box which is having a letter factor 1. So the factor or the level of this variable, as we have said in the example, is the time variable. So we should write time, and the number of levels are 3 because there are pre-intervention, mid, and post-intervention. So we need to write 3 over here and click on add over here. When you click on add, so it will be placed over here. So the measure name, that is the measure of the outcome variable. The name of the outcome variable, as we have said, is CRP, the C-reactive protein level. So we need to write the word CRP over here, and I should click over here, add. So when I say add or click add, so CRP or the outcome variable measurement will be placed over here. So hereafter, click on the define icon or box. So click on define, and then this will be the window where we are going to use most of our instructions. So here it says the within subject variables, and it is time because we have already told or ordered the SPSS that the within variables, the within subjects variable is time, having 3 levels. So we need to just bring all these labels of time by selecting all these at a time and then entering to this box. Okay, so again we'll go to this the plots, click over there, and we need to just take this time to the horizontal axis, and we need to add over here, and then click continue, and then EM means, click on the EM means and take this time to the box display means, and click on compare main effects and choose the Bumfor animated over here, and then click continue, and the options click on the descriptive statistics and effect size and the homogeneity of tests, and click continue, and maybe it's post hoc. There is no post hoc in this case because we have already repeated measures data and the categories are related. So the post hoc comparison will be just made by this EM window or comparison. We have said this is why we have chosen this Bumfor animated over here. So by using this EM estimation window, the multiple pairwise comparison will be done, Okay, so click on OK. These are the 16 steps that I have shown you in the PowerPoint in short. I think you were just following me when I was talking about the steps over here. So here are the steps that I have already used, and I made the plots within factors, and then add button, and then continue, and EM means the Bumfor animated has been already chosen. Continue in the options, and actually in the options, okay, what should have been, okay, effect size and descriptive statistics could be enough, and then finally, so these are the steps that we have already followed. So now let's have a look at on the output of this analysis, and it is taking a bit longer than usual, I think. Okay, let me just close it and run again maybe. Okay, click on Analyze General Linear Models and Repeated Measures, and over here write time and the labels. Okay, sorry, let me reset it first. Right over here time and then 3. Okay. Even though I have closed the output window, now the result has been displayed, you know. But it says homogeneity of, since I have ordered to do a homogeneity of variance test, it is saying or telling me a warning. So use the time and then 3, add, and the outcome variable is CRP, and add, and then define, and take all these variables to this window and go to plots, add time over here, and then add, continue, and then EM means take time to this box, compare means, and then choose the BEM for animated, continue, and options we need to select descriptive and estimation of effect size, and then continue, and then finally I said EM statistics, I think, plots and options. So then okay. Okay, I came back to you. So let's proceed to see the outputs of this one-way repeated measures ANOVA. We have seen all these results in the PowerPoint, you know. The first one is the within subject factor. That means the predictor variable having related categories 1, 2, 3, CRP, pre, mid, and post. And the mean and the standard deviation of the CRP level for each of the 3 categories with each observation. So these are the results that has been already displayed in the PowerPoint, and we have already seen it. Okay, so this is a multivariate test which could tell us the overall statistical significance. What we did not see in the PowerPoint is, you know, the Mauchly's test of sphericity. Whether the sphericity has been fulfilled or not, this Mauchly's test of sphericity could tell us. So here is the time variable, that is a predictor variable, and the p-value is 0.043, which is less than 0.05, statistically significant. So we reject the null hypothesis of homogeneity of variance. So that means the assumption of sphericity is not fulfilled, you know, it is violated. Therefore, that is why we are going to rely on using this greenhouse geyser in the tests of within subject factor to see whether there is an overall statistical significant difference between the related groups. So we should rely on the corrected techniques of statistical analysis, you know. We are not going to use this sphericity assumed result will not be used because the assumption is violated. So we need to look on the greenhouse geyser or maybe the Hunefeld and the lower bound, either of the 3, but it is recommended to use the greenhouse. So we can see that it is statistically significant. So there is an overall statistical significance difference on the CRP concentration level among the 3 related time groups. So that is the interpretation of this table. Okay, again the partial eta square also we can see, as I have said in the PowerPoint, around 75% of the variation of the CRP level has been explained by the time variable, you know. And here is tests of within subject contrasts, and actually the contrast when the time variable is being linear and being quadratic actually, and it should be a linear one, you know. We are not going to use the quadratic one. If we assume that it is quadratic, it is non-significant because the variable is continuous variable, so it is a linear. Therefore we should look over there in the linear, so it is statistically significant, you know. So there is a statistically significant difference between the groups of time variables in terms of the concentration level of CRP. Okay, this is a test of between subjects for the intercept, not for the variable that we include. We are not interested to talk about the intercepts, you know. Okay, the estimates or the mean level and the standard deviation of the outcome variable, that is CRP, are given here at each point in time. At the first time, at the second, at the third time. The mean, the standard error, and the confidence interval, you know. And finally, the pairwise comparison. The pairwise comparison, which is a very important one, and as we have seen in the PowerPoint, there is a statistically significant difference between time 1 and time 2 and between time 1 and time 3. The p-value you can have a look at over here. We have seen it already in detail in the PowerPoint explanation, you know. And the multivariate analysis test for this pairwise comparison again is indicating that it is statistically significant, and we can have a look at on the Wilks lambda. And the partial eta squared has been also given. And finally, the plot, the profile plot, will tell us how the pattern of the outcome variable over a repeated period of time, from time 1 to time 2, from time 2 to time 3. The concentration level of CRP at time 1, it was higher, at time 2 it becomes lower, and at time 3 again it becomes lower. So that is why we have just ordered this software to display the output for the plot, you know. So this is how you are going to use SPSS software for one-way repeated measures of ANOVA.